So we discussed in last slides, these values, okay, and we were saying that as t increases, the value of degree of freedom increases, t approaches the z functions, okay, the normality. Now this is what we have to also understand, that there is something called a test statistics. Please understand, do not confuse with statistic of that. That is also fine, but these are terms. So test statistic is generally explained parameter by error parameter. Okay, now what does it mean? It's very different, and we will take an example for this. So when we, if you remember, when we did regression, and I will show you this table after when you are done with these presentations, that when we go for regression test, there are parameters like confidence interval. When we were doing the cubic differentiation, cubic curve fitting and quadratic curve fitting, for the parameters value, the p value was coming, the t value was coming, the s value was coming. Okay, we will do that, we will get that. So what is that? So the parameter t is b, which is a coefficient we are trying to explain, divided by standard error. Okay, and right now we will just take example. Please pay heed to the data. There is ample data on the sheet. Okay, you can zoom in if you want to. Now suppose you need to understand that from this data 22, 24, 27, 26, 28 till 27, is the average mean 25 or not? That's the question. Okay, that's the question. So what we do generally, we find the mean, which is 25.17, and then we find the standard deviation, okay, square deviation variance. So we get it, you see, 2.44. Okay, this is all the, okay. Now we are getting a standard error, which is s by root n, okay, that is 2.44 divided by root 12, which is 0.705. Now what we are trying to say, this value of the mean 25.17, how close is it to 25? So minus 25 divided by the SE by root n is 0.24. Now we have got the value of t statistic. Please understand, as we talked about here, this one, x minus mu bar. So here x is 25.17, mu is 25, s by root n is 0.705. Okay, and the degree of freedom is 11. Why? 12 is the number of identities, and 1, n minus 1. Please see here, in the z table, on the left, on the first column, we had the first integer value of z, 1, 2, 3, 1 point, okay, in that way, 1.2, 1.3, 1.4, and in the top column, what we had, 0.01, 0.02, 0.03, that was z values. Okay. Now in the t table, we have degree of freedom on the first row and the alpha level. The alpha level at the top row or the header. Okay. So please see that first of all. I will zoom in. Yeah. Okay. Now please also see here the photograph. Most of the tables will have a photograph associated or graphic associated with it. Photograph and graphics are different. Okay. So graphic associated with it, and we have to talk in that way. Okay. Now here we are getting the shaded region. Again, you have to also always understand, the shaded region does the magic. If this would have it other way around, then it would have 0.60, 0.75 and those sort of things. Okay. Now what does it say? Our question, C for alpha 0.05 at degree of 11. Okay. So degree of freedom 11. Now please understand, it's a two-tailed test. Understand, here it is 0.05, but we are talking of two ranges. Okay. So we are trying to find a range as we talked. So t alpha by 2. So therefore we will go with this. So this is 2.20099, which is 2.21. Okay. So it is plus minus 2.201. Okay. Now what does it mean? Now I will explain to you step 7 and step 8. We are saying that for the degree of freedom 11, for the DF 11, the T to be like this, if this has to be 95%, then this is minus 2.21 and this is plus 2.21. Okay. We are saying this. Now we also are saying that our T observed, or primarily you can say T calculated, let us put it that way, T observed, not T observed, that is not the right word. T calculated is how much? 25.17 minus 25 divided by 0.705 is how much? Now it is lying somewhere here. I suppose if we draw a 0 here, it will be somewhere here. So our T statistic is lying in between the confidence interval. Hence we can say with 95% that yes, the data mean or the population mean from the sample which we have drawn, from a population of this we have drawn 12 samples, the mean is close to 25 and we are 95% confident. Okay, please understand. So the T statistic value is less than critical value 2.0 in absolute value, make a decision. Since the absolute value T statistic is less than this, we fail to reject null hypothesis, we do not have critical evidence, is different from this, which means, okay. Now please understand this language. How is this hypothesis word coming in between? Our hypothesis is the mean equal to 25 or not. This was our hypothesis. Okay. The alternate hypothesis is it is less, it is not. That's it, as simple as that. Now, as I told you that we are looking for, we are trying to reduce type 1 error. What is type 1 error? Reject H naught when it is true. So type 1 is reject H naught when it's true, and we want to reduce this error. So when the statistics come in the error region, when the statistic, the calculated, the 2.4 or whatever you calculated comes in the critical, this is also called critical statistic critical value. When it is more than the critical value, then it comes into the error part, and hence we say, okay, now we can say we are rejecting the null hypothesis, and when we reject the null hypothesis, we say the mean is not equal to, but where here what it is, because it is less than the T calculated. Again, this logic is simple, even if you follow that or you follow this calculation, this statement, because it is in this range, we can confidently say it is same, which means our null hypothesis is true. We are accepting our null hypothesis. Okay. So this is how we apply a test. Now, going ahead, this is one more distribution which you will hear again and again, a chi-square. We will use this again in detail, we will talk, I am just giving you a gist. So what happens is chi-square, it is actually summation of the random squares of random variables. Now we will discuss that also. Okay. So when with that we add those values okay, then only then we get this chi-square distribution. Okay. Now these colors are the degree of freedom, or as you can say, the parameters. You see, chi-square has one parameter, a positive integer k, that's why the number of degree of freedom. Okay. So the number of degree of freedom is k. As the degree of freedom is changing, this is the graph it is happening, and this is a cumulative. So how is cumulative got from a probabilistic distribution? Cumulative is integration of the probabilistic. The sigmoid function. Sigmoid function is an S-shaped function which we got in the normal plot. Okay. So similarly we get it here. Now I will show you a chi-square table. So this is a chi-square table. Again same thing here as t statistic. Okay. So we have a degree of freedom here, and we have the probability values. For a particular value, there will be a critical chi-square. So critical chi-square, critical t, those are the values or the boundary keys, as we can tell about. Okay. Now similarly, we have a chi-square, we have a F distribution. Now which says what? An F distribution is actually a ratio of two chi-square as written. Okay. Both have degree of freedom. One has degree of freedom d1, other has degree of freedom d2. The numerator is d1, the denominator is d2, and everything comes by that. We will not be calculating F statistic in our course, but we will be using F statistics, F value table, chi-square value table, t value table, z value table in our course. Okay. Now if you see the F value table here, kindly see here there are two degree of freedom, df1 and df2. So df1 is the numerator one and df2 the denominator one. Now if you remember, in t and z we had on the top row alpha values, but here because we have already df1 df2, this F table is different for each and every critical level. So we have a F table for alpha is equal to 0.2, we have a F table equal to alpha 0.05, and we have a F table of alpha 0.025, okay, 0.01. In this way, for each and every alpha there is a different Z table. Please understand, there is only one different F table, there was only one Z table, there was only one T table, one chi-square, but F, because there are two parameters already, df1, df2, there are different tables for different values of alphas. Okay, it makes sense? Yeah. And we will come to these distribution F and chi-square again in detail. I am just giving you gist that you should not get lost. So you understand T, on the basis of that you understand chi-square, on the basis of that you understand F distribution. Okay. Now, going ahead. So now we are entering into the field of statistics where we will be using multiple tests and talking about some tests and some variables and this and that. Okay. So please understand, a univariate variable, a bivariate variable, a multivariate variable. These are three simple categories. We can have multiple other also, but these are simple categories. So univariate relationship is, what is the mean? What is the median? What is sample variance? This is univariate, where only one variable properties are being described. Okay, it is description. Now when we go to bivariate, if you remember in our first class we will discuss probability statistics. One was describing, another was to to associate, to find the cause, or to predict. There comes the bivariate, because when you associate you need to, when you find cause you need to, when you are doing what we say prediction you need to, okay, at least two, more than two is also possible. So that is bivariate, when there are two variables. Okay, and it is bivariate, there has to be one dependent variable. As we said, x plus y is equal to 2, so either x or y has to be dependent. Okay. Now in multivariate we have multiple variables, 3 variables, 4 variables, 5 variables. So now I will just show you a back page of a famous book of Andy Field, which talks about most of the things. Okay, and you have to understand, we have not done all the tests. but we need to understand the criteria of test. And I will summarize this again. This is most elaborated. Okay? Just a second. Yeah. So, I don't know if we can zoom it. I will zoom it. Okay. Yeah. So, this is a summarization of the test to choose and the criteria to follow. The first question is how many outcome variables. So, how many dependent variables you have. Second is what is the type. If you remember our data type, we have 4 variables: nominal, ordinal, ratio and scalar. Okay. So, not ratio, scalar, interval. Okay. Then how many predictor variables. Okay. So, how many independent variables, how many dependent variables, that is the one. What is the type of predictor variable? So, we have a type for independent predictor IV and the predictor and the type for DV. Okay. And among predictor variables, if there are many, then how many are categorical. In this way, we will go and see that there are multiple tests. One may not remember this, okay. And for that thing, I am also giving you a link. Yeah, so this is very important. The whole statistics is very comprehensive, and this website called methods.sagepublication.com includes lectures about all the fields and primarily statistics or business methods. So, now you can see what is the purpose of your analysis. This is very important. To look for difference between two sets, or to look for association. Now, you might say, sir, there is no univariate. Yeah, if there is univariate, why do you need statistics? You can do it yourself. We go to summary statistics in the software, we will go there also, okay, and do that. Now, let us say to look for association between two variables. Let us say that. Next question. What do you want to do with the data? Measure the strength of association or predict? As I told you, association, causation and prediction. Prediction and causation are two different things. So, now we will look for association, we will look for strength, which is primarily testing how much they are associated or caused, right? Okay. Click here. See, what measurement levels are your variables? Okay. And as I did tell you that many cases interval and ratio are combined, ordinal, nominal are different. So, we will just say interval for the simplicity, though you can take this link and play with around it, or that table which has been given to you can be also be used. Okay. Now, this let us we assume. See. So, I have just given you this link, and on the basis of this link you can begin to study other things, though now we will go in depth of t-test, in depth of ANOVA, in depth of correlation, regression and chi-square testing and everything, we will go in depth. Okay. However, for the people who are more interested or more enthusiastic and want to speed up their learning, they can see this link and test their understanding for the other things. Okay. With that, I end this class right now. We will begin with summarizing these types of tests, and we will begin with means of from the next class. Thank you very much, and we end the session now.